Okay, so we're looking at the next part of the topic, which is first principles, and this is where we're going to find instantaneous rates of change. Okay, so what we're going to do is create a formula so that we can substitute any value of x and we can find the instantaneous rate. So this gradient, this is going to be the instantaneous rate of change. Okay, again I've misspelled instantaneous. Okay. Okay, so move across when you're ready. Okay, so what we've got is, like we've had before, so we've got a rise and a run. So I've got this value x, which is what I'm actually looking for, and I've got this other value x plus h. So across here, the function, rather than having y, I'm going to call it fx. So at this value x, the value is fx, and at this value x plus h, the value is fx plus h. So like if this was 2 and this was 3, this would be f2 and this would be f3, whatever f is. Like fx, like this is just notation, like fx could be like x squared plus 7x minus 1. It's just notation for the function. Okay, so the gradient is the rise over the run. Now the rise is the difference in the values in the y direction. So the rise will be the higher value minus the lower value, and the run is in this direction, so it's the higher value minus the lower value, and x minus x. So the run is going to be h. So the gradients will be fx plus h minus fx over h. Okay, and then if we're going to find this hopeless spelling. Sorry about that. The instantaneous rate of change is when we try to make this h value as small as we can, so that the little triangle is sitting right at the point that we want. Okay, come across when you're ready. Okay, so what we're going to say is the gradient is the limits. Like when we had in the previous slide, we had that gradient getting smaller and smaller to 6. What we're going to do is make the gradient, make the run as small as possible, by making h go to 0. So we've got fx plus h minus fx over h. Okay, and you'll find out in the next slide that we use a notation f dash x for gradient. Okay, so find the gradient at any point for fx equals that mess there. So we've got to find fx plus h. So we've got x plus h squared plus 3 times x plus h, it's an x, plus 1, and then we expand that out. Okay, so I'll just expand the brackets out. Now, we can go straight to the limit, so gradient equals the limit. So we're going to go this function minus this function, and what you'll see is x squared is in both functions, so that's going to cancel out. The 3x is in both functions, so that's going to cancel out. And the 3 is in both functions, so that's going to cancel out. So we've got just the terms with h left. Okay. Now, you'll see that these 3 terms all have h's in it. So we factorise, so we've got 2x plus h plus 3 over h, and then those h's cancel out, so I've got the limit as h approaches 0 of 2x plus h plus 3, and then what happens is as this goes to 0, then this goes to 0, so this just disappears, so we're just left with 2x plus 3. And that's our formula that we can use to find the gradient at any point. So e.g. if x equals 1, f dash x equals 2 plus 3 is 5. If x equals 7, f dash x equals 2 7s of 14 plus 3 is 17, etc. Okay, so copy and come across. Okay, let's do one with negatives. A little bit hard, a little bit slower, but let's go through it. So the gradient equals the limit as h approaches 0 fx plus h minus fx over h. So fx plus h equals 3 over x plus h. So change colours, make it a bit different. So the gradient equals the limit as h approaches 0 of 3 over x plus h minus 3 over x over h. Okay, now to simplify those things we have to have a common denominator, which is going to be x bracket x plus h. So we're going to do a little cross multiply. So it's going to be 3x minus 3 bracket x plus h all over h. Now these terms on the bottom here, they can come down and join the other guy down the bottom. So I've got x, h, x plus h. And on the top line, 3x minus 3x is 0. So I've just got minus 3h. Okay. So 3x minus 3x is 0, and they've got minus 3h. Now that cancels out with that, so I've got the limit as h approaches 0 of minus 3 over x bracket x plus h, and then as h approaches 0, that approaches 0, so that's gone. So the answer is minus 3 over x squared. And that's the answer. Then once you know what x is, so e.g. if x equals 1, then the derivative equals minus 3 over 1 squared, which is minus 3, etc. So copy that and come across when you're ready. Okay, so just make sure your notation. Okay, so gradient notation, and we also call the gradient the derivative. Okay, so gradient at any point is called the derivative of the function at that point. The different notations, you can have f dash x, you can have y dash, you can have dy dx. So what's happening here is this is the variable that we derive with respect to. Okay, and in some textbooks they use a dot on the top, but it's not used very often, but the main ones are the first three. So copy that and come across. Okay, so just to make sure, we can have different letters. So for instance, we might have a formula for velocity with respect to time. So the variables are different, so we can't have y and y dashes and things like that. So its derivative, okay, v's a letter, then v dash is the derivative, or we can say that we're deriving v with respect to t because t is the variable. Okay, so just be wary that you can have different letters. Come across when you're ready. Okay, so just to remind you, first principles, f dash x, oh no, I forgot to write the limits. So there's a limit as h approaches 0 of fx plus h minus fx over h. Okay, so f dash x equals the limit as h approaches 0, fx plus h minus fx over h. Now if you want to practice in cancelling the h's out, there's an exercise there, but if you want to practice the whole process, there's that exercise there. And I don't think there's another page, I'll just check. Nope. So that's it. Thanks, see ya.